How do we find the equation of a plane? That is a very, very, I guess it could be very, very hard to think of how to find an equation of a plane when your first instinct is probably something closer to the equation of a line, right? That would make sense. And it is close to the equation of a line. It's just that it's in standard form, right? It's not like slope intercept form, point slope form. It's not any of those because your equations of lines in 2D, there's a notion of slope when you have an equation of line in 2D. There's no notion of slope in 3D. So we'd have to use something else, and we have to use this identity right here. A dot B equals 0. What is this identity? A dot B equals 0 is a perpendicular identity of the dot product. That's not what it's called officially, but I'm just gonna call it that, right? This is A dot B right here, right? This is the A dot B. But is it the only A dot B? Is it the only A that's perpendicular to B? Well, that was supposed to be really cool. Of course not. Of course, it's not the only A that fits B, right? There's a lot of combinations. Even if you just like even if you just make a random A and then make a random B, there's a lot of possible combinations of X, Y's, and Z's that you can get that could be equal to 0, and we'll talk about that more in my linear algebra class that I will be starting in a couple of weeks time. But there's a lot of combinations of B's. It's not just one combination of B. It's not just one combination of A that's perpendicular to B, right? In fact, there's a whole plane. There's a whole plane of A's that are perpendicular to B, and that is how we're going to get our plane equation, right? Entire R2 of vectors A that are perpendicular to one vector B. That's how we're going to get our equation. Our equation is going to be of the form, you're going to see it like this: AX plus BY plus CZ equals D, where A, B, and C is your normal vector. So your A right here, or your B, I'm sorry, is A, B, and C, and then your yeah, and your A is X, Y, Z. It's a little bit complicated, right? This is really the equation, like the shortened form of the equation. The N is your normal vector, right? Normal to everything, and dot R is any vector in the plane, which is X, Y, and Z, right? X, Y, and Z is what we use for a vector in the plane. N dot R is 0, and that is the equation of the plane that crosses the origin, right? That is the equation of a plane that crosses the origin. Because if it doesn't cross the origin, we use something else. If you remember translations and rotations and stuff, for translations, we shift the plane right a little bit. When we shift the plane right a little bit in R2, we do X minus C, right? X minus something. So same with this. When we shift when we shift the plane positive a little bit in R3, we do X minus that point. Y, same for Y, same for Z. So still N dot R equals 0. The normal vector will still be exact same wherever the plane is. We're just shifting it a little bit. So R will be X minus X1, Y minus Y1, Z minus Z1, where X1, Y1, and Z1 is a point on the plane. Can be any point, it will still work, which is actually quite fascinating. Yeah, but it can be any point on the plane, it will still work. Yeah, I've already covered this. So this is the standard form. This is how you would usually see it. And we're going to work through this example. So the equation of a plane that contains this point with a normal vector -3, -1, and 2. Method 1, the first method you could do is you could do the method of this. So this is your method that you could do. You would do -3 times, right, x minus 1, because it contains this point, plus, or I should say minus 1 times y minus 3 plus 2 times z minus 0, which is just z, is equal to 0. Right? You would put this equal to 0 instead, not equal to d, which is what we will do in the next one. So negative 3x plus 3 minus y plus 3 plus 2z equals 0. And then to put it into this form, then we will have minus 3x minus y plus 2z is equal to negative 6. And that is your equation of the plane. And you could check it back. If you put 1, 3, and 0, you will get the equation of the plane. Method 2, what you can do is you could actually just plug the point in to a generalized equation of the plane. So it will be something like minus 3x minus y plus 2 is equal to d, or 2z equals d, right? Because we don't know what this constant is, but you can plug the point in. So you have minus 3 times 1 minus 3 plus 2 times 0 is equal to d. And you don't have to simplify in my test, but you really should simplify. This is not that hard. D is equal to negative 6. So negative 3x minus y plus 2z is equal to negative, that looks like a zz, negative 6. So yeah, I'm going to erase that. Okay, I didn't finish example 2. I am sorry. I am going to erase this. Okay. Shade the region. This is example 3. Technically, because we already did an example, so this should have been example 2, but I didn't do. I goofed up. Shade the region x minus y plus 3z is less than 15, right? So how are we gonna graph this? First of all, how are we even gonna graph this? Well, we're gonna use the normal vector to our advantage, and we're also gonna use the fact that we can just pick out any point. Right, so one point that's pretty clear from this is 0, 0, 5, right? So if we just do like one point that's on the boundary of this function is 0, 0, 5. So if we did this equal 15, then 3 times 5, then 0, 0, 5 is a point on this graph, right? 0, 0, 0 minus 0 plus 3 times 5 is 15. 3 times 5 is 15. You should have learned that in elementary. 0, 0, 5 is, well, if you did x, y, and z, that would probably be 1, 2, 3. Let's just say 0, 0, 5 is right here. Very easy point. 0, 0, 5. Now, this is a little bit hard for me because I'm using a mouse. But what's the normal vector? The normal vector is 1, 1, negative 1, and 3. That's your normal vector. Now how do I draw that? Well, something like that, 1 and negative 1, something like that, right? Or that's actually quite a lot. So something like that, and then something like that, and then something like that. So that would be your normal vector. Oh, I'm sorry. That would be your normal vector right there. Let's use a different color. So that's 1, negative 1, and 3. Now, you can kind of just go ballistic. Now you can just kind of, as long as it looks remotely perpendicular, I think it will fit. I think it will work. So something like that. There you go. That's your graph right there. That's your graph of equals, but I want less than. I'm sorry. Okay, let me just move this down a little bit. Okay, and then let me draw a giant ass plane. Right, so something like that. So that is how the function will look like, and it will cross the x-axis at 1500, which is like somewhere in here. So it works. And it will cross the y-axis at 0, 0, negative 15. 0, negative 15, 0. which doesn't really work. But it doesn't matter because we are not expected as human beings to be able to draw in R3 at all. Maybe it crossed somewhere here, something like that. But we're not expected to be able to draw in R3. But it's a good. Actually, this is a terrible plane. It's actually something more like this. Let me just draw. There you go. That makes a lot more sense, right? That makes a lot more sense. Yeah, it makes a lot more sense for this thing to be perpendicular to this thing. It still doesn't make that much sense because I'm really bad at drawing. Excuse my drawing skills. But it makes enough sense. So something like that, right? Now how are we going to be able to shade negative? How are we going to be able to shade negative? Like, this is a really hard job. I don't want to do this job anymore, right? So we just we'll just have to find a point, right? Let's just find a point that we know is less than, and then we'll see whether or not it's less than 15 or not, and then that entire region will the entire region will be shaded if that point meets the criteria for whether or not it's more than or less than. So it's either going to be like up here, everything up here, or everything down here, right? So let's see which one it's going to be. So let's use a point that we know is less 0, 0, 0, right? It's a little bit hard to see right here, but 0, 0, 0 is 100% in the bottom plane. It's not in the top plane. It's a little bit hard to see, so we'll probably use something even like less is 0, 0, negative 10, right? It'll probably be something, or 0, 0, negative 10, probably somewhere like right here, right? We know that's lower, and we know that 3 times negative 10 is less than 15, and that does fit the criteria. So in order to shade the region, there you go. That's your region. It's a little bit cringy. In fact, I think that's probably enough. But you can also, you want to do whatever you want to do, you can do it. But I'm not going to make you shade regions on the test. I will make you draw planes on the test, but I won't make you shade regions on the test. Just make sure that it looks decent, and that will probably work most of the time. So 45, we'll do 45, we'll do 53, and I don't even know if, okay, we should be able to get through these before 40 minutes hits. So find the point at which the line intersects the given plane, x minus y plus 2z equals 9. So which point does this intersect the given plane? We have x, we have y, and we have z, right? They're all in terms of t. And we can't really solve for 3 variables, so why not solve for 1 variable and substitute them in? So 3 minus t minus 2 plus t plus 2 times 5t is equal to 9. So 3 minus t minus 2 minus t plus 10t is equal to 9. So what's 3 minus 2 is 1, minus 1 is 8, so 8 is equal to 8t. That's really nice. T equal 1. Yeah, my test question is not going to be this nice. So the point is x equals 3 minus 1. And this, you can actually do this on my most tests. You could just leave it like that. You don't even have to simplify 3 minus 1, because that's just simple calculator shit, right, that you could do. So we don't want you to do something that a calculator could do. Determine whether the planes are parallel, perpendicular, or neither. Remember what I said about the vector scalar, or the vector multiple thing? So it's the same for this one. Normal vectors, just because the vectors are normal doesn't mean that they can be different when they are parallel. So if two planes like this, x plus y plus z equals 1, x minus y plus z equals 1, those planes, their normal vectors are 1, 1, 1 and 1, negative 1, 1. But they're 1, 1, 1 and they're 1, negative 1, 1. You can't multiply one of the vectors by any number to get to the next vector. So because of that, they're not parallel. Not parallel. Not parallel. Right? Not parallel. So what else is there left? Perpendicular and neither. Right? Now, perpendicular. Are they perpendicular? Well, let's see. So if one normal or if one plane has a normal vector of, let's say, like 1, 1, 1, 1, 1, that's really hard to draw. I'm just going to draw a random plane with this as the normal vector, right? So let's say this, right? And then if another plane had kind of the same, if another plane had a vector that's perpendicular, or, well, no, if another plane is perpendicular, just is perpendicular, like let's say something like this, or something like this. I am so bad at drawing, I'm sorry. So it's perpendicular. You could see that their vectors will also have to be perpendicular. So one plane has a perpendicular like this, one plane's perpendicular like this, their vectors have to be perpendicular as well. And that makes sense if you think about it. So how are vectors perpendicular to each other? Well, you just have to take the dot product and see if it's equal to 0. So let's do that right now. 1, 1, 1, dot 1, negative 1, 1. Is it equal to 0? It's not. 1 minus 1 plus 1 is 1. So they are not parallel, they're not perpendicular, and I'm not going to find the angle between them. I'm not finding the angle between them. But you can find the angle between them by doing the cosine theta thing, right? So the normal vectors, planes and normal vectors are pretty much they're pretty much the same. The normal vector is a characteristic of the plane that indicates the plane's direction, right? So because it indicates the plane's direction, you can use them in place for any vector in the plane. So what you could do is you could just do 1, 1, 1 dot or 1, 1, 1 dot 1, negative 1, 1 divided by the magnitude of the first one, the magnitude of the second one, which will be square root 3 and square root 3. So it'll be 1 over square root 3, and then cosine theta equals 1 over square root 3 theta equals like 30 something degrees or something, or a little bit more. But I'm not going to get through that because I don't want to use a calculator. Not today. Not today. So we're not going to do this. Next one is x equals 4y minus 2z and 8y. Okay. So we're just going to move everything to the other side. Let's do it right now. So x minus 4y plus 2z equals 0. And minus 2x plus 8y minus 4z equals 1. So these are the two equations you get. Are they parallel? Let's see. X and minus 2x minus 4 and 8. Can you multiply 1, negative 4, 2 by anything to get negative 2, 8, and negative 4? Yes, you can. You can multiply by negative 2. 1 times negative 2 is negative 2. Negative 4 times negative 2 is 8. And 2 times negative 2 is negative 4. You can multiply each of these by negative 2, and you will get the equivalent vector. The numbers on the right they don't matter, right? This basically just says that the one on the left is shifted a certain amount, right? The one on the top is shifted a certain amount from the one on the bottom, right? That's why the numbers are different, 0 and 1, right? It could be shifted by any amount. We won't know. It could be shifted right. It's probably shifted right in the x direction by 1/2, but an equivalent of that is it could also be shifted um, up by -1/8, or down by -1/8 on, or by 1/8 on the y direction. So there's really no, we don't know, right? We don't know which way it's shifted. So we're not going to try to figure that out. Now that is it for today's lesson. It's a lot longer than I thought it was going to be, and it's only going to get longer, in fact. But the vector is going to be pretty short, but the vector chapter is going to be pretty short, but this chapter is going to take pretty long. Um, so if you are using the James Stewart book, Multivariable Calculus, or Calculus Early Transcendentals in 2012, then you can do these problems to help you for the test, for just practicing your skills. 12.5, from numbers 2 to 5 odd, 7, 11, 14, 23 to 40 by 4s. By 4s means you do 23 and you skip 3, and then you do 27, so it's add 4 each time. 23, 27, 31, 35, 39. Too lazy to write all of them out. 63, 64, and all the questions from 73 to 75. And that's going to be it for today's lesson. We'll see you next time with Quadric Services.